Dear friends, welcome to another very exciting edition of Data Science Tutorials. Myself, Dr. Suptik Mukherjee. Today's topic is user defined functions, and this is part one of the series. But before we move on to the topic, I have a small request. Please don't forget to subscribe our channel. We put a lot of hard work and effort in creating these videos. If you subscribe, it will motivate us significantly. Now, uh, even before we go to the topic, this Jupyter notebook, including the code, will be available in our GitHub repository. For those interested, they can download this from the link given in the description below. Now, moving on to the topic. Why do we use functions? We use functions for several reasons, like code reusability, easy to deploy it in the same program or in different programs. Readability, that a function where the description is given well and the return value is given, then it is self-explanatory. And modularity, it's large code broken down into small pieces, each being a very complex code. That's the kind of modularity that we look for in a program. Now, say suppose, to give an example, I want to print my name 5 times, but instead of printing it, easier for me to define a function and just call the function 5 times. How do you do it? We start with def, which is definition of a function. This is the function name, and it has two parentheses and a colon. So now within this function, you print, I am Dr. Suptik Mukherjee. What is your name? So when you call the function 5 times, it's out there. Your name prints out. Next, within the print statement, you can call the function. Within the function, you can give a return statement. And the return statement can say, I am Dr. Suptik Mukherjee. What is your name? Now, when you call the function, the return statement is executed within this print statement, within this print function. And um, I have the name printed out. Now, for any function, it is important that you have a description and a return, because then it's easy to understand what this function is doing. For example, this function is meant for an introduction, and the return is, it returns my name and asks for another person's name in the string. Then abstraction. What is abstraction? Abstraction is, without trying to understand what the function is doing too much, what is happening inside the function, as long as I know what the description is, what the return is, I can use the function well. That's what we call abstraction. Simplifies the use of complex operations. So if I have a function, if I just call that function, the function name is introduction, and pass on the parameter Suptik, then name becomes Suptik. Name is assigned Suptik. Suptik is assigned to the name. And I am Suptik. What is your name? Now, instead of just Suptik, if I have 3 parameters, Suptik, Sam, and Alan, name 1, name 2, name 3, then we are, and if my return is we are name 1, the name 1 becomes Suptik, name 2 becomes Sam, name 3 becomes Alan. Now, instead of just 3 parameters, I have as a string, I have 1, 2, 3 as a string. But then I don't want names to be 1, 2, and 3, right? So I intend to put an assert statement where it says that, well, as long as it's a string, it's fine, else it will say it must be a string. So I use an assert statement. I use a is insistence function, and I have name1, which is a string. And then what happens? Then I print Suptik, Sam, and Alan. I pass on these parameters into introduction function, and then it says it goes here, right? So it says, okay, name one, Suptik fine, Sam fine, Alan fine. But then if it encounters, instead of Alan 1, 2, 3, it says name tree must be a string, and that's what it does here. Name tree must be a string, right? Now, instead of just parameters, I pass on a list which has three names: Suptik, Sam, and Alan. Then I need to unpack the list. And unpacking the list will mean name one as Suptik, name two as Sam, and name three as Alan. And then if I want instead of a instead of a just a list, I provide a dictionary. So what's going to happen now? Now you have a key value pair, which Suptik is 44, Sam 32, Alan 20, right? And then you need dot values for the ages. So this is name and age, right? So age is dot values. You need this function. This dot values this method this method, and then so uh, when you give dot values, and you total age will be sum of ages dot value. So ages, so add ages function, ages takes up the dictionary values. The total age is the sum of ages dot values, and these ages dot values will give 44, uh, 32, and 20, and you take the total ages as a sum, and the total age is printed out as a string. So it says our total age is 96. Now, instead of a instead of just the ages, total age being printed, I also want the name to be printed. So in that case, you have to use dot items, and then the dot items will, you run a for loop of name and age in ages dot items, and then you have the name printed out and age printed out, and it keeps adding the total age. Total age initially initialized to 0, and then it will print out the names and the total age. That's all, friends, for this video. Thanks for watching. Don't forget to subscribe, and happy learning.